good morning everyone. I am Nila Kapriani. Today I will going to explain about three fundamental concepts in mathematics. There are set, relation, and function. Now, these concepts are very essential because they form the foundation for many other mathematics such as algebra, calculus, and discrete mathematics. Now, in this session, I will not only explain about the definition, but also provide examples of the concepts so that the concepts are easier to understand. So, I will explain the concept of set, relation, and function with my PowerPoint. The first topic is set. In mathematics, a set is simply a collection of distinct objects called elements or numbers, or members, grouped together because they share some property or characteristic. Now, we usually write sets using curly brackets. Some are example, a set of all vowels in the English alphabet, and we have the set of A, E, I, O, and U. A set of number greater than 5, and we have the set of 6, 7, 8, 9, 10, and so on. Ways to describe a set. There are two common ways to describe a set. What is it? One, roster form, or we can call using elements. Nah, a roster form is the form of a set where items are arranged in a row and enclosed in curly brackets. Now, example, roster form of set of all natural number less than 10, and divisible by 3 is the set of 3, 6, and 9. Okay. Next, set builder form using a rule. Now, set builder form defines a set by specifying a rule or property that all its members must satisfy, rather than listing element individually. Example, the set of all x such that x is less than 9 and x belong to real numbers. Okay. Next, I have example of set. Okay, so some of the common example of set are one finite set. Now, example, a set of natural number less than 6, and we have B equals the set of 1, 2, 3, 4, and 5. A set of primary colors, and we have C is the set of red, blue, and yellow. The next infinite set. Now, a set of natural number n's is the set of 1, 2, 3, 4, and so on. Next, we have a set of real number greater than 0. And we have R plus is the set of all x such that x is greater than 0. And the last empty all we can call null set. Now, example, a set of moon with 32 days. The set of month of 32 days is the empty set. And a set of natural number less than 1, the set of natural number less than 1 is the empty set. Next, I will explain about operation of set. Operation on set are rules that combine, compare, or manipulate a set to create new sets. Now, some of these operations are first, union. Now, A union B is the set of all x such that x is an element of A or x is an element of B. Okay, then we have intersection. A intersection B is the set of all x such that x is an element of A and x is an element of B. Okay, you can see in the screen. Okay, next, difference. Now, the difference of A and B, or we can call A minus B, is the set of all x such that x is an element of A and x is not an element of B. And the last complement. If U is the universal set, the complement of A is A complement is the set of all elements in the universal set U that are not in A. Okay. Nah, then I also have solve example on set. One, set A is the set of 1, 2, 3, and B is the set of 3, 4, and 5. Find the union of sets A and B. Nah, the solution, the union of two sets A and B is the set of all elements that are in A, B, or both. Nah, and we get A union B equals the set of 1, 2, 3, 4, and 5. Nah, then 2, let A is the set of 1, 2, 3, 4, and 5, and B is the set of 3, 4, 5, 6, and 7. Find the difference of A and B, okay? And we get the difference of A and B consists of elements that are in A but not in B. And we got A minus B is the set of 1 and 2. Nah, okay, the next topic is relation. Okay. A relation in mathematics is defined as the relationship between two sets. Nah, if we are given two sets, set A and set B, and set A has a relation with set B, then each value of set A is related to a value set B through some unique relation. Nah, here set A is called the domain of the relation, and set B is called the range of the relation. Okay. Nah, example of a relation. Suppose there are two sets. X is the set of 4, 30, 36, 49, and 50. And Y is the set of 1, minus 2, minus 6, minus 7, 7, 6, and 2. And a relation R states that xy is in the relation R if x is a square of y, can be represented using order pairs. R is a set of order pairs, uh, 4 and and minus 2, 4 and minus 4 and 2, 36 and minus 6, 36 and 6, 49 and minus 7, and 49 and 7. Okay. Now, also the image it below shows two set A and B and the relation between them. Okay, you can see it in the screen. Now, representation of relation. We can represent the relation using different techniques. One, set builder notation. Okay, R is the set of order pairs AB such that B is twice of A, where A belongs to X and B belongs to Y. Okay, next, raster form. Nah. Okay, relation R is the set of all order pairs AB such that B is twice of A, where A is an element of X and B is an element of Y. Next, domain, range, and codomain in relation. First, the domain. The domain of any relation is the set of input values of the relation. For example, if we take two sets A and B and define a relation, R is the set of all order pairs AB such that A is an element of A and B is an element of B. Now, then the set of values of A is called the domain of the relation. Okay, next, range. Okay, range of any relation is the set of output values of the relation. For example, if we take two set A and B and define a relation R is the set of all order pairs AB such that A is an element of A and B is an element of B, then the set of values of B is called the range of the relation. Okay, the last codomain. Now, we define the codomain of the relation R is as the set B of the Cartesian product A times B on which the relation is defined. Now it is clear that the range of the relation is a proper subset of the codomain. Okay. Okay, okay, and I have a solve example of relation. Okay, find the domain and range of the relation. R is the set of order pairs of 1, 2, 2, 3, 3, 4, and 4, 5. Okay, and we get the domain is the set of 1, 2, 3, 4, and the range is the set of 2, 3, 4, 5. Okay, the next topic is function. Now, a function is a special relation or method connecting each member of a set A to unique member of a set B via a defined relation. Set A is called the domain and set B is called the codomain of the function. A function mathematic from set A to set B is defined as function f is the set of order pairs A, B such that for all A in A and B is in B. Okay, a function in mathematics is a relation between the input values uh, and the output values, and we call range of the given set, such that no one two variable from the domain set are linked to the same variable in the range set. Okay. Next, domain and range of function. Now, the domain of a function is the set of all possible input values, usually x, that the function can accept without causing any issues, such as division by 0 or taking or the square root of a negative number. Example, uh, f of x is 1 over x. Now, the domain is all real numbers except x is 0 because division by 0 is undefined. Next, range. Now, the range of a function is the set of all possible output values, usually y, that the function can produce when you plug in the values from the domain. Example, f of x is 1 over x, and we get the range is all real numbers except y is 0 because the output 1 over x never equals 0. Okay, types of a function based on mapping. There are several types of a function in math. Now, some of the important types are one-to-one, or we can call injective function. A function f x to y is said to be one-to-one function if the image of distinct element of x under f are distinct. Now, this f is one-to-one if f of x1 is f of x2. Okay, next, many-to-one function. If the function is not one-to-one function, then it should be many-one function, means every element of the domain has more than one image at a codomain after mapping. Okay, next, onto, or we can call surjective function. A function f, x to y, is said to be onto function if every element of y is an image of some element of set x under f. For every y element y, there exists an element x in x such that f of x equals y. And the last into function. A function f x to y is said to be an into function if there exists at least one element or more than one element in y which does not have any preimage in x, which simply means that every element of the codomain is not mapped with element of the domain. Okay, then I have a type of function based on degree. Now, first, constant function. A constant function is an important form. Many-to-one function in constant function all the domain elements have a single image. Now, the constant function is of the form f to x equals k, where k is a real number. Okay. Second, identity function. Now, the identity function has the same domain and range. The identity function equation is f to x equals x or y equals x. Now, its order pairs are of the form the set of 1 and 1, 2 and 2, and so on. Next, linear function. Polynomial function having the first degree equation is a linear function. The domain and range of a linear function is the set of all real numbers, and it has a straight line graph. Graphically, the linear function can be represented by the equation of a line y equals m times x plus c, where m is the slope and the slope of the line, and c is the y-intercept of the line. We can also write it in the form of f of x equals a times x plus b. Next, quadratic function. A quadratic function has a second degree quadratic equation, and it has a graph in the form of a curve. Now, the general form of the quadratic function is f of x equals 8 times x to the power of 2 plus b times x plus c, where a not equals 0 and a, b, c are constant and x is a variable. Now, the domain and the range of the quadratic function is real number. Okay, the last polynomial function. The general form of a polynomial function is f of x equals a to the power of n times x to the power of n plus a to the power of n minus 1 times x to the power of n minus 1, and so on, plus a times x plus b. Okay. Then I have solved example of function. Okay, check whether the function f of x equals 2 times x plus 3 is 1 to 1 or not. If domain is the set of 1, 2, and 1 over 2, and codomain is the set of 5, 7, and 4. Okay, and I have the solution. Okay, first, putting 1, 2 and 1 over 2 in place of x in f of x is 2 times x plus 3, and we get f of 1 equals 5, f of 2 equals 7, and f of 1 over 2 equals 4. Now, as for every values of x, we get a unique f of x, thus we can conclude that our function f of x is 1 to 1. Okay. Thank you. So that is my explanation about the concept of sets, relation, and function. I hope my explanation is understandable, and I apologize if there were any mistakes during my explanation. Thank you. Bye bye.